Welcome to AP Podcast 17.1. Ladies and gentlemen, it's our last chapter, and it is on electrochemistry. Very cool stuff. And look at this, applications of redox. So remember those redox reactions we did way back when in Chapter 4? Well, now we're going to see how they're used in an application. So if you think about a redox reaction, as you guys well know, or hopefully remember, in a redox reaction, electrons are being transferred, right? And so if you can move some electrons, that is the definition of an electron current, or electric current. So here's a typical redox reaction. Look at this. Permanganate going down to manganese 2 plus. Boy, how many times have we seen that this year? Anyway, so we've got a redox reaction, and as you guys remember, when we're going to balance something like that, we break it into half reactions. But what's a little different now is breaking it into half reactions gives us an idea of what's going on in what's going to be a galvanic cell. And that's where, think of it like a battery. It's just producing some electrons. So if we can separate these, we can get one thing to produce some electrons, as you can see right there, and one thing to kind of accept some electrons, and that, my friends, is the definition of an electric current. So that's what we're going to look at. Let's look at a couple things. Here's a couple beakers, and I put some iron here, and I've got a piece of, I've got a special electrode we're not ready to talk about yet. And I've got some iron 2 plus floating around and some permanganate floating around, and if we were to have some electrons generated, let's see, we had some electrons right here, and they were to go that way, they would flow along this wire, right? Flow along this wire in this direction until they got right here. However, as they got right here, they would build up. And would that cause more electrons to flow? Heck no, because you've got these negative things going this way into negative things. It wouldn't happen. So this doesn't work when you have a cell that has no connection. So in a galvanic cell, what we do is we put what's known as a salt bridge, and the salt bridge allows the electrons, as they're flowing, right? They're flowing in here. It allows ions to flow this way, and back this way, and back this way. All right? And so what we do is we get this pathway of the electrons to flow. Now, you might see a diagram in your book where they have a couple beakers attached, and they put this disc right here. But all that disc does is allow ions to flow. And so as long as ions can flow, we can get this cell to conduct, or electrons to flow. All right, so let's look at a couple other things that are described often in a galvanic cell. And as you can see right here, they've got the electrons flowing, and then imagine this is our salt bridge, or this is our porous disk, and we want to get a couple terms down. We've got an anode, okay, and at an anode, oxidation is occurring here, okay? So this end is producing electrons, right? And you can see they're all going that way. And over here at the cathode, reduction is occurring. And reduction is using up electrons. And we'll get into that a little bit more in just a second. But something to remember, because often, I don't know why this is, but often you see commercials like, not commercial, pardon me. Often you see questions where they say, what's occurring at the cathode? And the answer is reduction is occurring at the cathode. And so this is how I remember it. Here's another Richardsonism. Red cat. So reduction is always occurring at the cathode. Now, if you can imagine having some metal here, as electrons are sitting here, the ions, the positive ions, let's just say it's a Fe, 2 plus, right? They're attracted, so this thing gets a little bit bigger, this thing gets a little bit bigger, and if we have another metal here, as electrons are being reduced, the positive ions are floating out, and this thing shrinks and shrinks and shrinks. Okay, so there you go. That's some just basic bare bones stuff on a galvanic cell. And what we're going to do next is we're going to go ahead and put a voltmeter in there and measure this electromotive current, EMF, the voltage, whatever you want to call it. But that's the next thing. So we'll see you next time. If there are any questions, make sure you ask me in class.